Hello everyone. On this second slide presentation, we are going to talk about ways in which we can apply information we know about the normal curve. So, in preparation for this lesson, you will need a number of things. First of all, you will need your notes. You will want to go to page 3, section B. We will be camping out there for a little bit, and it looks kind of like this, either the notes or the PowerPoint presentation. You will also need a handout I gave you called the normal distribution. It looks something like this. You will need to have that handy. Please print out a copy because it will be difficult for you to not have a printed copy in front of you. And you will also need some paper and a pencil to do some calculations, and you will need a calculator. So let's get started by going to page 2, and I am going to make this a little bigger. Now, we will start here. The question we're asking is, how do we apply information about the normal curve so that we could determine the probability of a series of events happening, or the probability of a set of scores happening? So let's take the first example. The first example we have asks the following question. How do we find the probability of obtaining a score of equal to or greater than 115 if we know the following facts? That the mean score is 100 and the standard deviation is 10. So, if you recall from the previous slide, how do I do that again? I guess I didn't show you that. I should have. Yes, on the previous slide, I showed you this formula that you could convert scores to standard scores using this formula, that Z is equal to a score minus the mean divided by the standard deviation. So the thing that's new here that we wanted to find out is, how do you calculate Z, which represents a standard score? Well, given the example that I just gave you, we have everything that we need to calculate Z. All right, let's look at this again. We have the score 115, we have the mean 100, and we have the standard deviation of 10. So how do we go about doing that? All right, I'm going to show you that calculation this way. So I'm using a draw tool. I hope this works. It says that Z is equal to a score minus the mean divided by the standard deviation. And what we have here is the score that we have in this example is 115. The mean, we are told, is 100, and the standard deviation is 10. So if we break that down further, we do the top, which will give us 15 divided by 10, which equals 1.5. So take a minute and look at that and just make sure that you understand where we got everything from. We're using this formula to find the standard score, and the formula tells us we need a score, we subtract it from the mean, and then we divide those by the standard deviation. So if we go back to our example here, we are asking to find the probability of obtaining a score of greater than 115. Okay, so at this point, all we've decided is what the Z-score for 115 is. And the z-score for 115 we determined 2 seconds ago is 1.5. Now, what do you do with that z-score? So let's go to the standard, the normal distribution table. Now, let me introduce you to this table and then we'll get back to determining what we do with the 1.5. I want you to notice a number of things with this table. This table has 3 columns. The first column, column 1, gives us a z-score. Notice where my cursor is. Column 2 gives us an area between the mean and the z-score, and column 3 gives us the area beyond the mean. Okay, let's see if that makes some sense to us. I'm going to erase all this stuff. I'm sure there's a way for me to move around this table here, but I don't know, so let me demonstrate. Actually, I'll demonstrate on the right. I am now going to write, I'm going to show you a normal curve. Okay. Usually with a normal curve, one of the characteristics we said about the normal curve is that the mean is right at the center. In this case, we know the mean is 100. So 100 is at the center. Our question is, where is 1.5 or where is 115? Well, 115 would be somewhere on the right hand side of the mean. Something like that. And the question asks us to find a score that is 115 or greater. So we would be looking in the right hand side of the normal curve. Now, doesn't that look exactly like this? Let's go up to the top here. The area, column 3, is greater than the score or greater than, which is column 3. And of course, what that means then is that it's possible for us to find a z-score where it is the mean. This 0 here represents the mean, and the score that we would be looking at, that would be area column 2. Now that we know that, we could scroll down to 1.5, a z-score of 1.5. And a z-score of 1.5 is, if you follow my cursor, is where my cursor is. Okay? So, you go to the z-score and then you decide whether you're looking for the area column 2 or column 3. In this case, we established that we have to look at column 3, which is 0.0668. Let's try that again. We were looking for, we have a mean score of 100 and a z-score or a score of a 115, which brings us out here. And the question asks us for 115 or greater, which means it's 115 or more. So we have to look in area column 3. The first step is to convert that score to z-score units, which we did, and when we converted it, it was 1.5. And then we go to the area beyond column 3, which is 0.0668. So we go back to, so the answer to our question is 0.0668. One final thing we do is we convert these probabilities to percentages by taking this 2 decimal places to the right, which now brings this to 6.7%. Okay, so let's go back to our question, which is, if the mean score for a distribution of scores is 100 with a standard deviation of 10, find the probability of obtaining a score of greater than 115. And we just demonstrated that the answer to that is 6.67%. Well, let's very quickly do the second. let's just quickly do the second one, and you will see how we could do that here. And I will have to figure out very quickly a way of scrolling down here. Let's see. Okay, so what I'm going to do, I'm going to change this from 115 to 112. 112 minus 100 is really 12, not 15. So this here will be 1.2 and not 1.5. And so obviously this would not be the correct answer for this particular problem, which by now you should have been on your z-score table, your normal distribution table, to figure out what it is. Let me erase this here, and by the time we get to the next presentation, I'll figure out how you scroll down on this draw table. So we have to go to the z-score table to see what 1.2 is. We scroll to the z-score of 1.2, and the answer is 0.1151. So the answer is 0.1151 or 11.5%. So the bottom line is, as you notice, I converted everything to just one decimal place. So technically it's 11.51%, but I just rounded it to one decimal place. Very good. So what I'd like you to do is pause at this point, do the third one, and while you are doing that, I'm going to erase this here, and I'm going to tell you what the answer is for the third problem here. Okay, so while I'm erasing, you should be doing the computations and figuring out what the answer is. If I finish erasing before you get the answer, you could pause, and then I'm going to write the answer somewhere up here right about now. The z-score you should have gotten is 0.5, so the answer should have been 0.3085. So let me write that here, 0.3085, which is equal to 30.9. That's a point. Let's make that 0.9%. And this is a decimal in front of that too, which we just converted to percentage, 30.9%. So that should have been your answer. All right. Just go through this once or twice, and then we'll do an example for the, we'll do a couple of the second examples. And I'm going to demonstrate that in another presentation.